eye clicker I want to cover in 15.6? Last time somebody told me that I need what? What do I need? A cannon. The gavel doesn't do it. So, but no, don't get me any cannons, please. I don't have any space to put them in my bag. So, last thing that I talked about is the transformations in 3 triple integrals, right? That was the last thing. I didn't cover the last eye clicker question in 15.6. Now I want to start with 15.4. 15.4 is about transformation regarding what? Polar, cylindrical, and spherical. You guys didn't think we just, for fun, we were doing polar, cylindrical, and stuff, right? Now it's the first usage of it, basically. For the first usage of it, we're going to do this. I want to say, let's remember what general transformation looked like this. Sorry, guys. There we go. General transformation into D looks like this. You go from and double integral in region D in terms of x and y, and it's either this is ugly or that region is ugly, and you swap with f of x of u and v and y of u and v, and then the Jacobian. dA of u and v. I want to use another notation. Sometimes you denote that by f of g of u and v. Because x and y is g, right? Output g. Another thing, if this transformation is taking x and y, I mean, replacing x by r cosine theta, replacing y with r sine theta. Oh, this I forgot to put in, g inverse of d. If the transformation, what if polar? Then you will have f of r cosine theta and r sine theta. And then you will have a Jacobian g here. Then dA of r and theta, g inverse of d. Right? What is that Jacobian in this case? For polar, I can compute it very quickly. X sub r, x sub theta. You guys did this for spherical and cylindrical in lab, right? And y sub r, y sub theta, which is going to be, x sub r is going to be cosine theta minus r sine theta, sine theta, r cosine theta, which gives you r cosine squared theta plus r sine squared theta, which is equal to r. So this Jacobian is going to be r. That's how we do it through transformations directly. In the physics course and engineering courses, I have to say something else before getting there. When I say dr d theta, let me write this down. When I say dx dy, this is called, we've talked about this, this is called area element. That's dA of x and y. Order can change, right? It's an area element. Now, my question is, what happens to this area element on the other side? It becomes r dr d theta, right? So that area element swaps with this, basically. And you plug in. So that's why you have R times, that becomes equivalent to the area element. And then basically you just plug in R cosine theta for X, R sine theta for Y, and you find the bounds for R and theta. That's how you integrate. So what are the steps? What's the Jacobian for polar? R. How do I convert the integrand? Plug in R cosine theta, R sine theta, integral, transformation, use polar. One Jacobian is R, 2 replace X with R cosine theta, R sine theta for Y. What's the last part? 3, find bounds for R and theta, not for X and Y, for R and theta. Fair game so far? Example time? Oh no, before example, I want to tell you something. I'm still in that. Sure. Thank you. So, before the example time, I want to talk. Did I skip it? I skipped? No, it's next one. Let's do the example. I'm out of it. I thought that was first, but it was second. There we go. So here's an example. What's the first step? I know in my setup, Jacobian is R. Now, what is the integrand? That integrand becomes what? E to the R squared. Then are the bounds. How do I find the bounds? I look at the region. The region here is described. It's not given in terms of X and Y. But the description tells me how it works in R and theta. If it was given as in X and Y term, you basically convert, then you show it in terms of R and theta. So this is disk of radius 1. What region is that? R is between 0 to 1. Disk, what is theta between? 0 and 2 pi. You guys know this is basically non-elementary function, right? So non-elementary either in X direction or Y direction. Now what I'm doing is I'm swapping it with an R and theta, and actually becomes an elementary solution. Because it's bounded, elementary works, right? Otherwise, it wouldn't. So that's what I'm saying. Because it's bounded, there would be a number, and that's okay. But directly from X and Y, I would not get any answer. So what do I get? I get, and be careful when you're doing a chief. Sometimes you have to do that sort of things. So in here, I get e to the r squared dr d theta. R goes from 0 to 1. Theta goes from 0 to 2 pi. What am I forgetting? Jacobian R. And so the first step is to take the integral with respect to R. What kind of integral is this? Louder. It starts with U. And so U substitution, U equal to R squared. Du is equal to 2R dr, right? And so here I'm going to replace, wait, one more thing. If R is equal to U, what is U? R equal to 0. 0, r equal to 1, u equal to 1. So in here, we're going to have, I'm changing the inside, e to the u, 1/2 of du, again from 0 to 1, d theta. And so computation. This is the inner integral change into u substitution. So 0 to 2 pi, 1/2 of e to the u, 0 to 1, d theta, and that is 1/2 of e to the 1 minus e to the 0 is 1, d theta. It comes out, and I get 2 pi times 1/2 times e to the 1 minus 1. Fair game? From non-elementary, I swapped data transformation. I got an answer out of it without a computer. You saw this in Calc 2 a lot too. There was non-elementary then. You used the series and you did that. This actually happens a lot in that exact same thing happens in 526, Math 1, 526. Now, my next thing, you guys have seen this picture when in physics or engineering they talk about polar transformations. They say, well, the little element in here, that little element in there, or that little element is going to change into another area element. And that area element has r d theta is one side of it. It's almost, if it's very small, it's almost rectangular. One side of it is r d theta. The other side is dr. And that's why we have that r in there for Jacobian. I do like my transformation explanation better, to be honest. Transformation explains all of that, and then you always can draw a picture in the pre-image, basically. Your turn. What's that? How many eye clickers? I have one from last time and at least 2 here. Don't remember exactly. Is it 2 or 3 today? Beside that. Okay, someone tell me what are the bounds for R? 0 to 4. What are the bounds for theta? Pi to 2 pi. Now if I convert to x and y, what shape is that in x and y? I'm coming. It's a semicircle, right? Semi-disk, right? Yes. Again?
So I used my tablet, but they don't have my tablet. I tried my phone, but it won't let me log in on my phone.
Okay.
I tried to reset my password.
So write everything down and talk to me, but fix it next time. Questions? Honestly, I forgot your name. What's that? Dan. I should remember your name. Let me think of it. So how's it going? Questions? No? Questions? No? You're not in my class. You are? This is the first time I see you. I know him, but I can't remember his name. But the first time I see you, what's your name? Andreas. Lucas. Yes, somebody asked me, why is there an r squared there? Jacobian is there, and I have an x in here. Is it clicking? So x if I convert x, I get r cosine theta. And then if I have a Jacobian, it will be there. So it matches, the integral matches what it's supposed to be, right? So the next step is, did we get everything? Are we good? Well, I'm looking at this. If this is a disk, so R is between 0 and 4. Is it upper half of a disk or lower half of a disk? Lower half of a disk. So if it's a lower half of a disk, Y starts at the circle, ends at XY plane, right? So Y is ending at what? Y ending at 0. So, yes. Hold on. Why is it confusing about A or C? So, let's draw the picture. Let's draw the picture and see. I better not have made a mistake in there. This is y equal to square root of 16 minus negative y equal to right? And it goes to 0. Now, if I am doing, so it starts from, so I'm trying to say why this one is not right.
Because the x doesn't.
That's this. So did you guys, you told them if I was going to ask them. So x, let's see, x starts at what in here? Negative 4 to 4. Can it be A? No. So A is out. Now, what is the other option? The other option is going from it to it, and then y going from negative 4 to 0. Fair game? Everybody okay with that? Yes. Louder? That's what I was trying to explain. Look at this. X goes between what and what? Well, where does x go in here? No, it's not A. I just crossed it out. 4, 3. I crossed it out. I said it's not, this is not matching that. 4, 3. Can it be B? B goes from here to here for x, which is correct. Then for y goes from what to what? Why are we changing the numbers? Oh, no, that's C, that's C that goes right. Why is this giving you so much trouble? Yes, that's it. Look, goes from here to here, good. Goes from negative 4 to 0, good. I should not give you the answer. 4, 3, 2, 1, 0. You all be not talking after this. I gave you the answer. Too long. Okay. Too late, too little. So, now, gavel time. That's the last thing that I did last time. If I'm doing, tell me, if I'm doing cylindrical and spherical transformations, is it in 2D or 3D? 3D. So that's what I'm using. In spherical and cylindrical, You guys did it in the lab. In the lab. This for cylindrical is what? For cylindrical is R. For spherical, it's rho, no. I will make you memorize this one. A lot of things I'm okay, but that one you have to memorize. Rho squared sine of phi. Fair game? So if there is a spherical, you plug in rho sine of phi, cosine of phi, rho sine of phi, did I say phi twice? Rho sine of phi, cosine theta, rho sine phi, cosine theta, rho sine phi in here. If it's cylindrical, you plug in r cosine theta, r sine theta, and z. And then you find a bounce. Ready for finding one? We're good? Okay. Remember, you owe me. That eye clicker took too long. You owe me once. One at least. Yeah. You should have done it faster. There you go. Okay. That's what I'm meaning. I should not do this, even though I like it. Okay, so what are the steps? Step one, what is your Jacobian? Oh no, step one, should I use cylindrical or spherical here? Look at this, I see a lot of x squared plus y squared. Does everybody see a lot of x squared plus y squared? One, that's like 1 minus x squared, quantity x squared plus y squared. I see it over here, I see it over there. That's actually a good clue, because everything transforms to r squared, right? So that tells me maybe I should transform this to cylindrical coordinates. So I'm thinking cylindrical coordinates. Cylindrical coordinate, what's the Jacobian? R, thank you. Thank you to this group who are answering, and those who are not answering, answer. Now, the next step is that you want to transform your integrand. What's the integrand here? What's the transformation of the integrand? F of x of r theta z, let's say g of r theta z, is going to be r squared. That's the integrand. Now, I want to set up the bounds. Hey, what are the bounds here? What are the bounds in xy plane? These are the boundaries in xy plane. Your first step should be converting them into r theta and z. How do I convert the cylinder? This would be r squared equal to 1 or r equal to 1. Now how do I convert z equal to 4? In cylindrical, it stays z equal to 4. How do I convert the paraboloid? Z 1 minus x squared plus y squared, right? That is z equal to 1 minus r squared. So all the conversions are done. Fair game. Now I'm going to tell me, guys, is there any limitation besides 0 to 2 pi on theta here? Is there any surface that stops theta? No. Theta is going to be between what and what? It's not necessarily always, but here there's no surface bounding theta. So theta is going to be between 0 and 2 pi. Now, the next step that I want to do is this. I want to find, because theta can be the most integral. I want to find the projection of these shapes onto, I'm still on step 3. What is step 3? Finding bounds. So theta, I know that it's going to be, so I have to find this projection on R and Z. There's a Z equal to 4, right? And then I have, what do I have again? I have R equal to 1. And then I have 1 minus R squared. I didn't do a good job. 4 should be higher. Do you agree? Then I have 1 minus R squared, which looks like that. So that's the projection on R and Z. Basically, in R theta and Z, if this is 2 pi, it will look like this. I didn't do a good job. That is too long and not parallel. You get this little box that there's a dome underneath it. But in X, Y, and Z plane, you know how it look like. There is the cylinder, and there's a little ball sitting there upside down. Just like that. I don't draw very well under pressure. So that's the shape that you get in X, Y, Z plane. I'm going to use that to set up my bounds. So now you guys tell me, in the RZ plane, is this X simple or Y simple? I'm sorry, R simple or Z simple? Does everybody see it's a Z simple? It is a Z simple. I attached these two too much, but you can see it's not going this way, it's not simple. Going upward, it's simple. So what is Z between? Z is between the lower bound, which is what? Upper bound, which is 4. Upper bound is 4. R is, then I can say R is between 0 and 1. Everybody agrees so far? We're good? Now I'm setting up the integral. You ready for the integral? So, can you see the entire thing? Okay. So the integral is going to be inside 0 to 2 pi d theta. Then I will have dz because it was z simple. Z goes from 1 minus r squared to 4. Then I will have the r goes from 0 to 1. Should be constant, both sides. Now, what is the integrand? Break. Yeah, this one can switch anywhere. It's okay. But the most important part is that this doesn't have any surface restricting it. You want to draw these two. You want to draw R and Z for that reason. Because those restrict, the surfaces considering R and Z are restricting each other. Now, what was the integrand, my friends? Am I done? Why am I not done? Jacobian, so I have R cubed, as they say. What's always there? You always have the Jacobian, yes. 0 to 2 pi r cubed d theta dz dr. And then you do d theta gives you 2 pi r cubed 1 minus r squared to 4 d z dr. And then you get what? You get z 2 pi r cubed z 1 minus r squared to 4 dr 0 to 1 2 pi r cubed 4 minus 1 plus r squared dr, and I lost interest after that. It's 11 pi over 6. You can see this, you have to distribute and find. You ready for a spherical? Are we good? No, before spherical, I want to talk about this. By the way, what I just did, do you guys see that yellow over there? So that yellow is basically, I said, I'm going 2 pi, and then it's basically what I'm taking the integral, the double integral over elements like that. What I did is a shell method in disguise. You literally can have, it's the shell method, right? So the most inner integral, when you get rid of it, then you will have the most inner 2. When you get rid of it, you get the shell method. It's analogous to shell method. And if I was going to do in the R direction first, I would get the washer disk method out of it. I think you have an example that you do in lab that is non-simple. You find it out. That's something I wanted to say. Spherical time. Let's do spherical. What's the first step? Jacobian. What is Jacobian? Memorize this. I literally will ask you a question memorizing this, please. After this, I give you an eye clicker. Fair game? Okay, 2 eye clickers to sweeten the deal. Gavel time. Now, what's the first step after that? Integrand. What is the integrand? So integrand is y. Convert. What would y be? Cosine. Oh, whoa, yeah, sine of theta. What's y? Thank you, thank you. You saved me. There we go. So integrand is this. Now what else do I need? Bounds, right? I need bounds. I have a y equal to 0, and I have y equal to x, right? So let's see. Y equal to x, let's convert. What do I get? I get rho sine phi, it's right there. Sine theta equal to rho sine phi cosine theta. What does that give me? Sine theta equal to cosine theta. So what is that? It's pi over 4. I can divide by cosine theta. In pre-calculus, we learned that we can divide by cosine theta and get tan theta equal to 1. So theta pi over 4. Okay. And that matches the picture, right? Theta equal to pi over 4 is right here. So can anybody tell me what y equal to 0 is in here? So y equal to 0 gives me, let's say rho can run anywhere. It gives me sine theta equal to 0, right? It gives me y equal to 0 is the xz plane. What is xz plane? Xz plane is theta equal to 0. So sometimes the conversion, you have to kind of put in some other efforts in it. So now this is a case that theta is not constant. Theta is bounded besides 0 and 2 pi. It's not a full rotation theta, which is fine. So there's one other thing that I need. What's the other thing that I need? There's another. It's an orange slice, so unit ball sliced. I forgot to bring my orange. You have an orange, you do a slice out of it. And that's a unit ball. What does unit ball mean in terms of unit ball? What is that? Rho is equal to 1, so rho is between 0 and 1. Oh yeah, I forgot to say theta is between 0 and pi fourth. Okay, now your question is where is phi going? Phi? Takers? It goes from 0 to pi, it goes full range. Within the boundary of theta, it goes full range. So phi goes between 0 and pi. All set, integrand sets, let's integrate, right? I will not do a full integration, but. So integral for theta was 0 to pi fourth. For phi was 0 to pi. Agreed? For rho, what was rho? 0 to 1. What was the integrand? Rho sine phi cosine theta. What am I forgetting? Jacobian, rho squared sine phi. Again, now you have to integrate as integral from 0 to pi. Oh, you can separate this actually. You can go sine cubed phi, which you have to use Pythagorean, 0 to pi. Cosine phi. Did I say phi? Oh, I see. I saw your looks. I apologize. Integrand, I converted wrong again. And then 0 to 1, rho to power what? Rho cubed d rho. These two are easy for you. The last one to remind you is sine of phi times 1 minus cosine squared. Phi and u substitution, cosine phi. That's it. I'm not going to finish it. But there is a finished notes on your lecture notes. Oh, I messed up, didn't I? How many sine do I have? 2. Sorry about that. So let's change the method. This method is going to be 1 minus cosine 2 phi divided by 2. Integrate that. What am I doing right today? Okay, let's do this again. This was wrong, and that was wrong, and that was wrong. Everything else was okay. Sounds bad. So that's the integral. Now I want to do, let me do one more problem, or should I do the iClicker first? You're tired, okay. Let's do iClicker, then I do the problem. Oh, yeah, it's covered. Sorry. So if I'm computing the volume, what should the integrand be? Integrand for volume in triple integral. 1. So wait, first one is out, first and second are out, Jacobian is gone. These two have Jacobian, the last one doesn't have a Jacobian out. So among the two that have Jacobian, we want to find the unit sphere, so phi has to run from what to what? 0 to pi. And then theta has to run between what and what? 0 to 2 pi. Which one is messed up? Which one's correct? Everybody got that? No, I mean, did you understand it though? Okay. Don't yell out the answer. 4. Questions? 4, 3, 2, 1, 0. Okay, let's go back to this example, and I give you one more iClicker and send you home. So here's the example. Find the volume of this solid. Again, do you guys want to do cylindrical or spherical here? Yeah, so it could be a nice cylindrical also. But you know what? I am going to assign this as cylindrical in your worksheet. So you can compare it with this. Can I do spherical just for fun of it? Okay. So let's do the spherical for fun of it. This one is called, that was orange slice. This one is called ice cream cone. So what is it? There's a sphere on top. Which one is the sphere? And a cone on the bottom. So ice cream cone as goes with that. So first step, second step, what is my integrand? Integrand volume. 3, let's change the boundaries. So how do I change z equal to, how do I change this one? Again, you're going to do this in cylindrical, then compare, see which one you like better. Z equal to rho, I'm doing spherical. Rho sine of phi. Oh, what is x squared plus y squared? So x squared plus y squared is rho squared times sine. Rho squared times sine squared phi. Agreed? Sine of phi is always positive. So it comes out without a plus and minus. Sine of phi between 0 and pi is always positive. Sine between 0 and pi, always positive. Has nothing to do with, it just has to do with that. So that's the cone. Oh, wait. So cone is what? phi equal to pi fourth. Now, what is this sphere? That one is rho squared equal to rho, I said sine again, cosine phi. Agreed? Rho squared equal to rho cosine phi. So rho is going to be equal to cosine phi. I have all the boundaries. Let's find the bounds. Phi starts from up top, ends at here, so between 0 and pi fourth. Now, theta, what does theta do? 0 to 2 pi. Rho is getting complicated. Rho is between cosine of phi and 0. Wait, is this true? Should we check? How do I check? Is theta a full rotation? Theta is a full rotation. So I'm going to check between. So in theta, rho and phi, I'm going to find the relationship. Phi equal to pi fourth. Oh, can I switch, by the way? It's supposed to be theta phi rho. So phi goes all the way to pi fourth, right? Look at these two. Phi is between 0 and pi fourth, and rho equal to cosine of phi. Rho equal to cosine of phi. What is the cosine shape, my friends? That. So it goes down, but what is cosine of pi fourth? Square root of 2 over 2. Tangent is. So it kind of ends here. And then it drops down. So is this rho simple or phi simple? Going up is simple, right? So rho simple. So rho is between 0 and cosine of phi, as we said. I'm checking what I wrote over there. This is rho equal to cosine of phi. That's phi equal to pi fourth, and phi equal to 0, and rho equal to 0. Fair game? And that's the, by the way, if I had continued it out of here, it would look like that. It would look like a bread loaf. Okay, set it up. Triple integral, rho squared sine of phi. D rho goes from 0 to cosine of phi. D phi goes from 0 to pi fourth. D theta goes from 0 to 2 pi. And then you solve. And then you can try the other one. Do you want another eye clicker quickly? Let's close it down with an eye clicker. Thank you for your patronage of my eye clicker. You love the eye clicker? Remember, this is 15.6. 15.6, and you're trying to do transformations. Hey, Michael, we want to swap the error. You're Michael or you're Henry?
Michael.
Michael. Which one? No? I haven't answered you. I'll email you back. I'll come back. You emailed me, right? I haven't answered you. I just looked at you, remember. Okay, so U and V are given, right? Okay. So can you solve for x in here? Can you solve for x in terms of U and V? If you add them together, you get 2x is equal to